Yeah, so we're going to talk about how to build NLP models, so natural language processing models. We're actually going to start very simple, and then we're going to go to a far more complex model. And kind of the whole idea is like, just like the title says, it's like demystifying it. Everyone thinks like machine learning and AI is like super difficult. And like this is hopefully to break down some of these barriers, and it's far simpler than it actually sounds. So hopefully we'll do it by example. And I'll have some cool resources for everyone here at the end so that they can try it out on their own. So my name is David Von Thenen. I am a AI ML engineer at DigitalOcean. I've been in the AI ML space for some time here. I particularly came from an NLP background, although I love doing vision-related stuff, RAG, building IoT edge models, doing AI and ML on edge, even like training medical models to detect disease. Prior to that, I was in the Kubernetes and CNCF ecosystems, so working on open source Kubernetes. And then prior to that, I was doing backup recovery solutions for virtualized environments, specifically VMware vSphere. So the agenda today, we're going to do kind of like the hello world. So this is a very basic, we're going to build a model right here. And it's going to be a very basic model that is a classifier to identify whether a sentence is a question or not. I kind of think of this as a very simple hello world. And then we'll move into something far more difficult, but easily digestible here. So we'll do a named entity recognition model. I think in the talk on what it was actually going to be, we'll talk about it at the end. But for doing redaction, you have to do named entity recognition first before you do the redaction. And then we'll do a demo. I'll do it live. We'll have several demos actually, and I think 3. And we'll have a bunch of resources for you to try this at home, and then have a bunch of Q&A. So our very first NLP model. And I'm going to kind of start level set with some terms, just to kind of break this down, make sure that we can all understand all the terminology and all the jargon. So whenever you build like a machine learning model, it always starts with a data set. So what's the domain that you're trying to do, whether it's natural language processing, whether it's doing images and vision related classification, whether it's doing medical analysis with MRI images, you have to start with your data set first. This is like what you're trying to identify, classify, that whole bit. And with that data set, the whole idea when you're doing classification is that you're trying to find patterns that exist in this particular case in language, right, in natural language processing. So once you have your data set, you need something to like decompose language, right? So sentences, and you do that by a tokenizer. And everyone kind of has heard, like large language models are kind of just next token prediction engines, and they are. In fact, you break down language to very concrete small blocks, and you just basically predict of the next block, and then the next block, and the next block. And so there are a lot of ways of doing that, and there's a couple of them here. And we're going to use the first one, which is BERT uncased. So BERT is a natural language model that came out of Google, and it's case insensitive, and it's basically trained on the English language. There's a whole bunch of other ones that are, language agnostic, where it works on multiple. But this is a great simple one where you can start with to tokenize or break down your sentences into single words. And then there's another one that's DeBerta, which is kind of like a slightly more advanced one that came out of Microsoft. What's really interesting and cool about that one, in the tokens, or the smallest unit of measure for DeBerta, doesn't have to be words. It can actually be like syllables, which is kind of very interesting, like broken down words. And it's kind of really fascinating. So you have a data set, you have something to break down to get to an individual token, then you have a machine learning framework. And this is something like PyTorch, TensorFlow. And then I have Fast AI here, which is kind of very interesting. It's kind of meant as a beginner's or starter's guide to like hiding a lot of the complexities away from PyTorch and TensorFlow. And it's kind of an easy way to get started with doing machine learning. And then I even started with that a long while ago. And once I kind of got like the knack of it and like understanding how to build a classifier, I evolved away from that, and now I use PyTorch, and we're going to use PyTorch here today. I have some other terms that are, you hear, like a tensor is just a measurement. It could be multidimensional, but it's just a measurement. So whenever you hear the word tensor, think I'm measuring something. And then some other popular frameworks are Pandas and NumPy, or NumPy, however you want to pronounce it. They're just other ones you should take a look at. It helps you manipulate data in large tables and contexts, right? So for your first NLP model, NLP models specifically, classifiers are they're like the basic foundation. When you build a classifier, in this particular case, if we're building a classifier to determine whether or not a sentence is a question or a normal statement, it's literally two types of classification. Is this a question? Is this not a question? And so when we're building a machine learning model, you need to start with a data set. And this sometimes can be very difficult depending on the problem that you're working on. And so curating that data set and finding that data set is sometimes very difficult. In this particular case, there's actually a data set that already exists that provides, it's called the Stanford Questions and Answering Data Set, or SQUAD for short. And so you actually, if you go to the Stanford, I think it goes, well, it was a data set that was curated from Stanford University, and it literally has questions and then the associated answer to that question. So if you're trying to build a question and a sentence classifier, this is actually a great resource, a great place to start. If we have this data set and we are trying to classify whether a sentence is a question or not, we can literally break it down and put them into two categories. Grab all the questions, and I can actually show you when you get to the demo. Grab all the questions, or grab all of the sentences, whether it's a question and an answer, and put them in one column. And then the second column, if it's a question, you literally have a 1, and if it's a sentence, you literally have a 0. And so if you're trying to build a question classifier, when you present a question, once you train your machine learning model, and you present a question to your classifier, it's literally 1 or 0. Is this a question or is this not? And so when you build a machine learning model to do a question classifier, it is literally that simple. You have the tokenizer that will take all of the sentences that you've provided, sentences, questions, and everything. It'll break down the sentences into words, and it will find the patterns that exist in those sentences. When it finds those patterns, it will see that there's a 1 or a 0. Is this a question or is this not? And it's the simplest, NLP classifier that exists because it's super simple. Column, sentences, 1 or 0. Is this a question or not? So it turns out this problem is actually far more complex than it sounds. That is actually how you build the classifier. But what's kind of very interesting about this is, if you're trying to build a question classifier, couldn't you just look at the end of the sentence and look for a question mark, right? And it turns out that if all of your sentences have question marks at the end, your machine learning model will literally learn that if there's a question mark at the end, this is a question. And so there's actually some things that you need to do in order to make it so that it doesn't do that. We have some sentences here, and what's kind of very interesting is some of them are very simple, like, is this an example sentence? Question. So this is obviously a question. My name is John Doe, period. Obviously not a question. How are you doing, my friend? So there's no question mark on the end of that, but we know that it's a question, right? Because we just know that, right? It starts with how, usually who, what, when, where, or how. Is usually another identifier. So when it breaks down, so when you're building your machine learning model, it's going to tokenize and pull out the words that are contained in the sentence, and it's going to learn and it's going to identify that how is going to be an identifier to classify this as a question, independent of having the question mark at the end of the sentence. Now the last one is very interesting. Tell me about the history of the United States. That is a question. It doesn't end in a question mark. and it doesn't even begin with who, what, when, why, or how. But when you ask someone this, you're eliciting a response from that person, and so we want to have this come back as a question. And that's why this problem's slightly more difficult than it sounds, because we want to have that last one come back as a question. And in fact, when we're going to build this machine learning model out, it will actually do that, which is kind of cool. So let's just go ahead and take a look. So I have, it's already pre-built because it actually takes some time to build this, but that Stanford question and answer data set that I had talked about, I'm going to open up the dev version of it so it's much smaller. So you can actually see it's in JSON. You can see the question here, and then you can see the possible answers. And what you can do when you build this out, you put the question and the answers in one column, again, and then 1 or 0. Is this a question or is this not? No, it's not. We're going to extract it out of the JSON and then put them into a CSV or just a CSV file. So if we actually want to take a look at that. So when you do the extraction on that, and there's this main.py which actually does that. If I deleted all of the CSV files here, it will actually download the Stanford in question data set. It will extract that out. It will create a questions data set. Oops. Right? Questions. What do atoms form? Comma 1, which means it's a question. And so it'll grab all of the questions, extract it out from that JSON, put them in there. I've separated them out so you can actually do cat. Where is the non-questions? So these are like non-question, right? It's just text, right? It's a standard sentence, comma 0, not a question. And then they end up getting combined into this data set here, basically merge the two CSV files into one CSV file. In the main, it will train the machine learning model based on that CSV file. And believe it or not, it will come out, you'll have a model that pops out the other end, and then when you actually run it, is this an example sentence? Is a question. My name is John Doe, not a question. Tell me about the history of the United States, question. And so, believe it or not, it sounds like I'm like glossing over a bunch of stuff. The point is, it's literally that easy. Like 2 columns, sentences and questions, 1s and 0s, train the machine learning model. Its job, like PyTorch's job when it's deconstructing and decoding everything, its job is to handle all of that stuff for you. Train the model, it outputs this model right here, and then you can inference it by giving it test questions, which are these ones right here, and it will tell you whether or not it's a question or not. So it sounds incredibly simple, but literally that's kind of like the point of this hello world. It's literally that simple to get started. So no, it doesn't have to be. So we'll actually get into the next one, which is the more complex one. So cool. Here's just a summary for your own information, just a recap of everything. In the data set, so like all of the questions had question marks at the end, all the sentences had periods at the end. For 30% of the data contained in both of those categories, I removed the punctuation. And the reason why I did that was because when I type, especially like on Slack or something, I don't punctuate half the time anyways, commas or anything like that, right? So removing that basically then forces your machine learning model to learn that it's not all about the question mark. Super simple example. Let's now scale that up. So we're going to build a named entity recognition model here, which is also redaction, but we need to start with the named entity recognition first. So what are named entities? name entities are extracting and classifying things in sentences mentioned in unstructured text into predefined categories. So if anyone's heard about like personal identifiable information, protected health information, payment card stuff, so like credit card numbers, CVV, those are all different classifiers or classifications for things. So like my name, David, the classification is name, right? If I was like my address, the classification would be an address. So kind of like the point of it is when you're building out one of these classifiers, in this particular case, it's a named entity recognition. Think of it just as taking the text and associating a label to it, so that when you want to classify it, it's going to see what that label is and understand that that word is classified as that particular label. And that is literally how you build out a named entity recognition model. I think we had a question. Like identifying medical words and, yeah, 100%. So what's interesting is you start with sentences, because we're talking about natural language processing. You start with sentences. Whatever you choose to identify or what you're interested in, you would associate a label or something to it. So if you were talking about a movie database, you have a list of movies that you've curated from IMDb. You understand that these are titles. You would attach title to those words, right? That's kind of like the very basic breakdown of it. Right. Yes. Right. Well, I'm going to get into this. I'm going to decompose that. Yeah. Okay, so the most difficult part is where to get the data, right? Again, everything starts with a data set. So for named entity recognition, this is actually a well-known way of classifying data, right? People need to redact or remove personal identifiable information from transcripts. So there are already existing data sets, thankfully. You don't have to make your own. I basically linked to a whole bunch of them here. This first one is amazing. It's literally a GitHub repo with links to other data sets. So if you're looking for Twitter data, if you're looking for movie database stuff, if you're looking for world history stuff, it has like links to all of these other data sets that you can label yourself or just use the existing label that's there. And if you're building a named entity recognition model, there's actually already a format, and it's cool that all of these resources here, all these data sets and these links up here are already labeled in this CONLL formatted data set. And these data sets are curated and created by researchers and people who are interested in doing text classification. And thankfully, you can just go ahead and download them, and you can use, if you want to use the predefined labels that they have, you can go ahead and do that, and that's what we did for this particular demonstration. But again, just remember that you're just associating a label to a word or a group of words, which I'm going to cover in a second here. So again, just the CONLL format is a widely a standard that's widely available. It's a super simplistic view. Again, I keep driving this home, but just like the 1 or 0 is a label it's a very simple label for a sentence or a question, you can attach multiple different kinds of labels to words. And so in the case of like personal identifiable information, like if you give your age, you would literally just use an age label. If it's my name, you'd use a name label. And what that looks like in the CONLL format is this. So we have a sentence, United Nations official, I'm going to horribly mess up that person's name, heads for Baghdad, right? You can see the sentence right here on the left-hand column. It turns out with machine learning, you don't need these two middle columns. It's actually, you can strip it out, and In the code that I provide, I actually do that. So the only two pieces that we actually care about is that word column and what that entity tag is. And so if you look here, United Nations is one organization. And you want to treat United Nations as one holistic unit. And so the way you do that when you're kind of tagging or labeling your data is that you have this B or I. So beginning of my organization, and then an I, which means your continuation of that particular entity. So United Nations is the beginning of, United is the beginning of the organization, Nations is happens to be the last one, but it's the continuation of that organization label. And so this person is B because it's the first time. So if I use my name, David Von Thenen, David would be B person, Von Thenen would be I person. And then Baghdad is B location, right? And so, again, it sounds crazy, I know, but you take these labels, you assign them to the individual words, and if you use the data sets that I've mentioned already, they've already done that, right? They already have those sentences that are broken down with the entity tag on the other side. And so if you're just curious or interested about like identifying organizations, people, locations, using the default data sets that are there, you literally just hit train, and when you want to use and classify sentences, it will actually pull out like, this is a person's name, this is a location. And it's the, like PyTorch and those machine learning frameworks, literally it's its job to identify how these things are organized based on the labels that you're interested in. So if you wanted, for whatever reason, to be notified for heads, like that word, just I don't know why you'd want to, you could literally attach a label that says, B heads, right? And you'd get notified anytime you wanted that particular word or those groups of word classified. So if you were doing IMDb for like movies, you'd have like B movie for like, I don't know, what's a movie these days? Whatever your favorite movie is, if it's more than one word, B would be the first, B movie would be the first word. The next word would be iMovie, 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 iMovie. And then when you train the machine learning model, when you say, I'm interested in movies, it will give you that whole chunk as one huge chunk for that entity. Yes? No, so that BERT tokenizer that I talked about so that's case insensitive, and I did that on purpose so that we don't have to worry about case. Yep. And it turns out if you use public data sets, sometimes the data is labeled horrifically, and it happens all the time. And so even though you have public data sets, definitely take a look to make sure that they're correct. It's just the way it is, and the reason why is that when these data sets get curated, a lot of the times, we pay people to go ahead and label the things that we care about in sentences, if we're talking about NLP, and people make mistakes, and it happens far more often than you think. And why it matters is that if your words are not labeled correctly, with the words that you want to identify are not labeled correctly, it will unteach what you are interested in classifying when you're trying to get entities out. So it's really, really important that when you provide data and you ingest it into your data set, that everything in that data set is as pristine as it possibly can be, because you don't want to kind of like accidentally teach or unlearn like iLocation, for example, like to identify locations. And so if we were to build out, and this is where it gets slightly more difficult, and actually I probably should mention, the O entity tag means we don't care about this. We're not interested in this word at all. So it turns out that if we want to build out a named entity recognition or anything that we want to classify, like a movie recognition system or actor recognition system or whatever it is, what the CSV file seriously looks like is, which I'll show you in a bit, is that sentence and then a new line character to the beginning of another sentence, and then a new line character for the beginning of another sentence. And in the second, or these multiple columns that are there, so if we don't care about that particular word, so like if we take a look at the word is, it has a tag of O, which means I don't care about this. And then all of these other ones are zeros because we don't want it to be classified as the beginning of an organization or the continuation of an organization. And then in the case of the United Nations, it is an organization. We do care about it, so we need to apply a tag so that we can classify that grouping of words as an organization. So United would be the beginning, Nations would be the continuation of that organization, and so on and so forth. So if you're interested in like time, like June 3rd, 2012, you can literally, B time would be June, I time 12, 2012, I time. And when you say, give me all of the time entities that exist in this sentence, it will actually do that, providing that you provide enough in your data set for it to teach it, right? And again, we're using BERT uncased, so we don't care about casing at this time. Yeah. So let's go ahead and take a look. Anywho, okay, so let's just go ahead and feed it some sentences. So we train the model, so that's what this main.py does. It will take all of the named entities that we have defined here. So these are a whole bunch of different named entity data sets. So you can see, this is one that just came out of, I think it's like the CONLL. They actually have a conference, and every year they come out with a whole new data set for people to use for publicly. Here's a movie database. I think this was in the music database. Just stuff off the internet, SEC filings, which we're going to end up using in the demo at the end. So these are different data sets for different things. And I literally, in that main.py, it's already been pre-labeled. Every word in there has already been pre-labeled with something. Actually, let's just go ahead and take a look at one of them so that you know that I'm not kidding. I'm just going to pick one random one. So this is like what one file, which contains multiple sentences, looks like. So you can see the second incident took place near 00000, which means we don't care about this. We don't ever want to classify these words. And then I'm guessing this is location because it's tagged as B location. And this is also a location. So this happens to be whatever these two words, I'm going to Kavi Nagar. That's one entity for a location, and we want to group them together, so that's why it's B location and I location. And literally, if you have enough data that is labeled in the way that you want it, you can literally use PyTorch. It will go through, train itself to identify and associate all of the different patterns that are associated with making those labels associated with those words so that you can classify words and sentences. And so what that ends up looking like, so we'll just take a look at this last sentence. So the Eiffel Tower is one of the most famous landmarks in Paris, France. So after we trained the model, which is contained in NER model, after we trained PyTorch, went through all of that data, it built the model out so that it can do named entity recognition. we took this sentence and we used it as inference. So we basically took this sentence, passed it into the model, and it said, based on all of the labels that we've trained you to identify, return all of the labels in this sentence. And in this particular sentence, it recognized Eiffel Tower as a location. It recognized Paris as a location because there was a comma there. A comma is technically a word, or it's like a token. And so France came up as a second location. And if we take a look at some other ones, just John Doe donated X amount of money, $5,000 to the Red Cross during 2020. So this is a slightly more complex example. John Doe, so given name. So I trained this, I added additional labels in here so that you can do given name, family name, $5,000, right? B money, I money. Red Cross is an organization. B organization, I organization. 2020 is a date. And so if you just use the data set, that's all of the data sets that are there with all of the labels that are already there, train it, pass a sentence in, it will do named entity recognition. And it's, again, I know this sounds incredibly simple, which is actually really cool. The whole point of this is like demystify this. This is like, everyone can do this. You don't have to be a data scientist. You don't have to be an ML engineer. You don't have to be an AI engineer. It's literally, it's that simple. So don't be afraid and build all of the things. So if you're looking to build out a, again, like a movie recognition database, you would have like, if you had sentences or titles for movies, you would literally label it like B movie title, I movie title, actor's name, like actress name, and so on and so forth. I think we had a. So that's what's cool about it is if you give it enough sentences, in the way that the sentence is structured, it will find the pattern to understand that this is a particular location versus maybe Paris the name. That's a great question. And actually the code that I've provided here, main.py, maybe to your point, is there are definitely words that you would want to label as two different labels, right? So maybe, do I have one that's an example of one here? I don't. Because usually when you pass the sentence in, based on the context of the sentence, it will return the label based on like what it is, like a name versus a location.
Can we run this with a sample sentence like, yesterday Paris Hilton visited Paris, France?
So we can. We'll give it a try. So by the way, also too, that this named entity recognition thing, it has definite flaws in it. Like, don't use this for production. This is more an illustration or an example of like how you do it, right? I, believe it or not, spent weeks combing through this data to try to fix as much of it as possible, but it is far from perfect. So just as a heads up for it. But yeah, sure, let's try it, why not? In my face. How well? You got that. Oh. It should have returned, in the cases of multiple tags, you would have B location, I location, and I think it's just my output is a little screwy on it, but I didn't go like super in depth into making sure that this is like production worthy, but play around with the code and whatnot. So, okay. Here's just some information for you to kind of like talk about what I had just said. Oh, we're running out of time, aren't we? Shoot. Here's a recap. So if you want to do redaction, you have to be able to identify what it is that you want to redact. So to do a redaction of names, you would first identify a name and then replace it with star, 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 star to redact it, right? So, two cool models that you can build. So let's build a real-world application based on these two models. So let's create a virtual AI assistant. Let's assume, and I know this is a console application, but I'm going to talk into the microphone, and anytime it identifies that it's a question, I'm going to actually have a computer voice generated call out to ChatGPT or any other LLM, answer the question for me, and then speak it over the microphone, and hopefully we'll get a response back. And it will also take the sentence and break it down so that it will identify all of the named entities within that sentence. And I've also programmed it so that based on the named entities that we want or we care about, it will give me 2 cool facts about that particular named entity. And why this is kind of cool and important, if you were to do this and build out a virtual assistant and you are in a sales call, you could do all sorts of cool things like if they mention that they live in a particular area, it will identify that area as a location. It will give you two cool facts about that particular location, and you might be able to use that information to build rapport with your person on the other end. And so a lot of companies do this to do call center assist, sales assist. So they basically mine the conversations that are happening, and when something interesting comes up, it will prompt the user or the salesperson or the call center person with information on how to help that particular user on the other end, if it's a call center related thing, or if it's a sales call, maybe it's, again, something to build rapport, or if the customer mentions that they are interested in this particular feature, it will deconstruct the sentence based on the labels that you're interested in, and it will say, you can program your machine learning model to say, hey, I saw that this customer mentioned this particular thing. We actually have 2 products that do exactly that, and it pops that pop-up in front of your salesperson so that they can actually kind of parrot back saying, oh, you know what, we actually have these 2 things that are available in our catalog of products. So that's why this is kind of useful. So let's go ahead and give this a try. So I'm going to spin up a REST API on top of that question model, REST API on top of that named entity recognition model, and I'm going to talk into the microphone. If it's a question, we're going to have a computer voice speak over the thing and answer the question for me, and every sentence is going to get classified for named entities contained within the sentences. So let's go ahead and give it a try. Hopefully this will not blow up in my face. Here's the service for the question. Here is the service on top of the named entity recognition. And then I'm going to start a small demo application that's simulating a meeting type environment. I live in Long Beach, California. Where is Microsoft's headquarters located?
Microsoft's headquarters is located in Redmond, Washington, USA.
I'm going to stop it there. Okay, so the question classifier identified the first one as a sentence, so that's why we didn't have the computer voice respond and give me an answer. It did detect 2 entities, Long Beach and California. That's actually where I do live. And here's information about Long Beach. Maybe in your sales call, you can say, oh, you know, I've never visited the Queen Mary, and I've heard it's pretty interesting. That I know it was used in World War II or blah, 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 right? And, you know, we all know about California. So here is, Yeah, so where is Microsoft's headquartered located? Call that to ChatGPT. Again, use the LLM of your choice to get this response from the question so that we could speak back to us. It identified Microsoft as an organization. It gave me some facts about Microsoft, Redmond, USA, and that is it. Resources. So I will tweet, if you follow me on social media or whatever, Blue Sky, X, Twitter, LinkedIn. I'll tweet out the slide deck and everything. You can click the link at the top, which will take you to my GitHub repo to build all of this stuff at home. And if you don't have a computer with a GPU on it or whatever, I have a Google Colab notebook for everything that I did here, and also a Kaggle notebook for everything that I did here. So you can build the question classifier, you can build the named entity recognition. If you want to deploy this on your laptop like I did today, I have all of the resources to download this with instructions on how to set up this exact demo on my laptop here. And then some resources for like the speech to text and stuff. And then that last link for the repo, super cool, has all of the different things. But again, kind of the point is if you are particularly interested, you don't have to use those, the repo with all of the data sets. You can build your own data set based on what you care about. And that's kind of like the point of this talk here. And that's it. Any questions? Yeah.
Oh, so from my understanding, the biggest bottleneck to these machine learning models are high quality data. And I know that a lot of the time that's really hard to get access to a large amount of high quality data. Do you are aware or know or recommend any strategies for if you have a small amount of, high quality data, but you want to expand your data set without too much effort?
Yeah, 100% you're right. The biggest difficulty is obtaining the data set. Like, believe it or not, if you look at the main PY code that trained the named entity recognition model that you have access to that's on my GitHub, the code is there, but the most difficult, and it's not even that long, I think it's like 500-600 lines of code to train it all. The most difficult part's the data set for sure, and you have to get creative. Either start academic torrents, Kaggle. Believe it or not, there's a lot of people that are posting really cool data sets for things that might be of interest to you, but 100%, that's the most difficult part. So if you wanted to build a question classifier, another way that I actually had done it was instead of using the squad data set, I just basically grabbed a whole ton of links from Wikipedia, parsed the HTML, scraped it, and for everything that had a question, I moved it aside to have it be a question. Everything that didn't have an end in a question, I moved that to be an answer or a standard sentence, 1 or 0, lopped off the punctuation at the end, and now you have a data set to classify questions. But yeah, you have to get creative. In talk that I did yesterday with my co-speaker here, we needed to find a way to detect Parkinson's by gait or by someone walking in a video. And believe it or not, we did it, we built it. Me as a person who doesn't work in the medical industry, I'm not a researcher, I'm just a person who loves machine learning and like to do this stuff for fun. Where do you get that data to find like people who are walking across a camera that actually exhibit Parkinson's disease and normal people walking? And so for our data set, we went to YouTube, TikTok, and Instagram, and we downloaded video of people posting stuff about Parkinson's disease, and that's where we obtained the data set for Parkinson's classification. So you have to get a little creative. Think about different ways of obtaining it if you don't work for whatever, these large companies, like Google, Facebook, they're sitting on a ton of like a data mine of information, public, your information. So that information is easily available for them. But for us, search, there's a lot of researchers that publicly post their data sets, which is really cool. And otherwise, get creative.
So how resource intense is all of this from, actually the setup that you just ran right now to actually creating your own data?
Yeah, so you mean like to do the training?
Yes.
Yeah, so the training, okay. So the question classifier without a GPU, just using my M3 here, it took roughly about 45 minutes based on that data. And I actually did this because at first I was like, oh, how long could this possibly take? And the joke's on me for the named entity recognition. I literally had my laptop on for 23 hours and it finally outputted a model. With an H100, the question classifier was like 2 or 3 minutes. And then the named entity recognition model was like 25 minutes instead of literally 24 hours on my laptop here.
Okay, then I had another question. What is it, the API that you use for text?
Wait, sorry. And by the way, I work for DigitalOcean. You can spin up GPU droplets, train your models, and then shut it down, and you're only paying for the time that you're using that GPU droplet. Sorry, I got to do the company plug, sorry.
So can you use the text-to-speech API with, like an open source offline model like Llama or something else?
So if you're looking for other models to do other things, like one really great resource is like Hugging Face. Go to Hugging Face, they have like a whole bunch of open source models to do natural language processing, to do speech to text to speech. That's a great resource for you to take a look at. And then if you find that like in the case of like BERT or DaBERTA, which is the Google and Microsoft NLP model to break down language, if you find something that is close to what you're looking for, you can fine tune, which is literally what we did here today. You can literally fine tune those models to make them question classifiers or make them entity recognition models. And so you can start with one of those as a base, fine tune them to turn them into something that whatever it is, problem that you're trying to do. Last question down there at the back. I appreciate you running back and forth.
My job.
So, and I don't know if this is actually a problem with LLMs or like just a theory, but I've heard that supposedly if they get like a really long prompt, it can be a little bit more unpredictable and maybe not have the best output. Is there a similar problem here if it's trying to parse too large of a sentence or a paragraph?
It should be okay because what I assume is actually happening under the covers, it's taking the sentence, it's understanding the structure of the sentence, and then it's looking at the structure of like the pattern that is closest matching to that label. If it's an O, then we throw it out and we don't care. And if it's like a location, then you get it. So it's basically understanding what had happened before, right? And then when it comes to the token for the location, like a location, for example, it's looking at that and saying, oh, I understand that this is a location, and it's popping it out. So it's literally handling it one token at a time. Cool. Again, definitely, I appreciate everyone being here super late. But check out those the Google Collab notebook, the Kaggle one, and believe it or not, I kind of copied word for word what I kind of had just said here into those notebooks so you can revisit it just like if you were here today. So, cool.